Hello everyone. So I'm going to solve a second problem also in development length. So uh, yeah, the difference is the first problem was the development length on beam, and this second problem is on development length of slab. So this is problem number 2. So same problem, similar problem, but this is for slab. The previous one was for beam. This one is for slab, and the question is same. Find out the development length. Development length LD equals to. So what is given? Given is this is a slab. Longitudinal view looks similar as beam, and this is the beam, and this is a beam, and this is the slab. Similarly, there's a bottom bar, and of course there's a load, right? So the load is WF, and what else is given? The thickness of the slab is 300 millimeter, and total span is given 6 meters, and this steel rebar is 20 amber at the rate of 300 millimeter spacing. So the steel rebar is given 20 amber 300 millimeter spacing. And what else is given? The clear cover is 25 millimeter clear cover, and because of its very corrosive environmental location, that's why this it is epoxy coated river was used, and determine the development length. Question is determine the development length. The other thing is I need to draw the bending moment diagram. So the bending moment diagram is the maximum in the midpoint. So that is the maximum, and 0 in the bottom in one side and 0 on the other side. And the other thing is given is the Fy is given 400 MPa, and F prime C is given as 30 MPa normal density concrete. So those are everything given. Now I need to determine the solve the problem. Can change the color to blue this time. Blue for slab. So we are solving the problem for slab and development length. So solution. What is given? So the given is first of all diameter. When you solve the problem, please always use the actual diameter. But for this problem, I'm solving it for the number. So the bar diameter, we are assuming that multiplying 2 diameter bar is 2 multiply 20. So 40 millimeter, which is less than 300 millimeters. So now we started to put all these values: K1, K2, K3, K4. So K1 is 1 because it's bottom bar. Just one thing is, if you're calculating for top bar, then the value is different. So remember that if you're doing it for top bar, then value is different, but because you're doing it bottom bar, it's 1. So then K2 is 1.5, because why? Because we use epoxy coated bar, epoxy coated rebar, and also we used a 25mm clear cover. See, remember this 25mm clear cover from there to the bottom. And we also can calculate 3 diameter B is 3 multiplied 20, which is 60mm, which is more than the 25mm clear cover. So because of that, so we're using K2 equals to 1.5. K3 is equals to 1 for normal density concrete. And K4 equals to different, it's not 1. Who can say what is the K4 value? So the K4 value is 0.8 because we used 20 amber. So less than 3 amber, less than 30 amber. So that's why K4 value is 0.8, not 1. So now we put everything in the equation. So the equation of LD equals to 0.45 K1, K2, K3, K4, and then Fy by root over F prime C multiply the diameter. So if I put all the values, 0.45, first one is 1, then 1.5, then 1, then 0.8, then Fy is 430. So 400 divided by root over 30 multiply diameter bar. As I mentioned a few times again, once again, when you will solve the problem in assignment or exam, you should always use the real diameter. But for this case, I'm using just the number for just learning purpose. So, but diameter is 20 amber, so it's 20. So multiply by 20. So you get the value is 789 millimeters. 789 millimeters. So what is the distance for the maximum moment? So this distance to the maximum moment value is half of the span. So this distance is L by 2, which is L is 6 meter. 6 meter. So 6 by 2 equals to 3 meter, 3000 millimeters. So L by 2 LD, which is 789 millimeter, is less than 3000 millimeters. So then if we provide the whole all the way to the end, so it's sufficient, and there's space, available space, and it's sufficient. So what is the, if this is the maximum moment point, so the LD value is from there. So if it is this, LD equals to 789 millimeters, and from here to here, LD equals to 789 millimeters. Okay, so we calculated LD for a slab. The first problem was on beam, and this one is on slab. So we'll need this calculation when we'll do the slab design. We'll need this like LD distance from the maximum moment point to that distance, and also for top bar. For top bar, using this value, but it's, remember the K1 value will be different. So using the top bar in that area, in the on one support and also in the other support. So then the K1 value will be different, and it will be because of the top bar, and the distance will not be from middle, this distance will be from the end. Okay, so this is the end of this problem.